Today we're going to talk about non-deductive arguments. I'll also call these inductive arguments. I'll use non-deductive and inductive interchangeably. There seem to be a lot of good arguments whose premises do not guarantee or necessitate the truth of their conclusions. And these are what we call non-deductive arguments. So here's an example. Every horse that has ever been observed has had a heart. Therefore, every horse has a heart. Now, the premise doesn't guarantee the truth of the conclusion. It's possible that there's some heartless horses out there in the world that we just haven't observed yet. So this is not a deductively valid argument. And yet it still seems like the premise does give support. It does give evidence for the conclusion. And it does. So we want to contrast here the strength of inductive arguments with the kind of characteristics of deductive arguments. If you've got a logically correct deductive argument, we call that valid, and that means it's impossible that the premises are true and the conclusion false. But a logically correct inductive argument, we call it strong. We don't call it valid, we call it strong. In a strong inductive argument, it is possible but unlikely that the premises are true and the conclusion false. Now, logically correct deductive arguments that have true premises, we call them sound. Logically correct inductive arguments with true premises, we call cogent. This table here summarizes some of the differences between the two kinds of arguments. One thing to point out here is that an invalid deductive argument gives no support whatsoever to the conclusion. But support comes in degrees when we're talking about inductive arguments. So, if you draw a conclusion based on 2 observations, that's weak. If you draw a conclusion based on 10 observations, that's a little bit stronger. If you draw a conclusion based on 1 billion observations, that's very strong. So support comes in degrees. It's not all or nothing with induction. It's important to point out that induction is what science basically relies upon. Science generalizes from observation, and that's all about induction. Now, we're going to look at 3 different kinds of inductive arguments. The simplest kind is called induction by enumeration. And that's the kind that we looked at with the horse. Here's another one. Every 24 hours of my life, I have observed the sunrise, so therefore the sun will rise tomorrow within 24 hours. It's based on past observation. It generalizes to the unobserved. In induction, one relies on similar observed cases to infer that the same event or property will recur in unobserved cases. And the degree of rational belief in an inductive generalization is going to vary with the amount of confirmation that the generalization has received. But if you get one negative counterexample, that's going to defeat an inductive generalization. If one time 25 hours goes by and the sun has not risen, well, that defeats my whole generalization that says every 24 hours the sun rises. Obviously, that's been falsified. Another kind of non-deductive or inductive argument is hypothesis testing. Again, think the scientific method. This is when you propose a hypothesis and then you test it against the facts. So let's say that we observe that the town's water supply is different. It's funky in some way. I don't know. Maybe its color is different or something. I don't know. And we form a hypothesis about why that is. And our hypothesis is factory runoff is polluting the town's water supply. Well, if we want to test that hypothesis, we would consider what things we would expect to observe if that hypothesis were true. So for example, I would expect that people drinking the town's water would be far sicker than those who aren't drinking the town's water if in fact it's being polluted by factory runoff. Or I would expect that if the factory was temporarily shut down and the water supply got cleaner, that would confirm the hypothesis that the factory was responsible for what was going wrong here. So if the expectations are borne out, then the hypothesis is confirmed. If the expectations are not borne out, then the hypothesis is disconfirmed. But confirmation here may come in degrees. I mean, maybe some of the things that you expected to happen did happen, and some of the things that you expected didn't happen. And in that case, you've got kind of partial confirmation of the hypothesis. But you're generalizing from observations to something that you haven't observed. You observe the consequences, and you're generalizing, you're making a conclusion about the causes of those effects. There's also inference to the best explanation. And in this kind of argument, a conclusion is inferred on the grounds that the claim made by the conclusion would explain all the facts that are presented. So let's do a Sherlock Holmes example here. The first time that Holmes meets Watson, he observes this. Watson is a gentleman of the medical type, but with the air of a military man. His face is dark, but his wrists are fair. His face is haggard. He holds his left arm stiffly and unnaturally. Holmes tries to think, what's the best explanation for all of these facts? What would make sense out of this entire picture of this guy? And he comes up with this explanation. Watson is an English army doctor who was wounded in Afghanistan. Now, how strong is his support for that conclusion? Well, it's strong just to the extent that his explanation can make sense out of all these facts, right? So, and Holmes thinks that his explanation does explain each of these facts. It explains why he's a gentleman of the medical type. He's a doctor. It explains why he has the air of a military man, because he's in the army. It would explain why his face was dark, but his wrists were fair. He would have got that tan pattern in Afghanistan. Why his face was haggard, battle fatigue, and why he holds his left arm stiffly and unnaturally, because he was wounded. And furthermore, if the English army was in Afghanistan engaged in battle, that would explain the convergence of all these different facts. So the ability of the conclusion to explain all the observations, that's what determines the strength of this inference. Now, non-deductive arguments can have false premises, right? So take this example. Every horse that has ever been observed has had 2 hearts. Friends, that's not true. And you might conclude from that, though, that therefore every horse has 2 hearts. Well, what do we do with an argument like this? If the premise were true, it would give strong support to the conclusion. So, however, the premise is false. So what that means is this argument is strong, but it's not cogent. It's strong because the premise strongly supports the conclusion. It's not cogent because the premise is false. Non-deductive arguments can also have uncertain premises. So take this example. Every horse that has ever been observed has had an even number of hairs on its body. Therefore, every horse has an even number of hairs. Now look, if the premise were true, then that would give strong support for the conclusion. So this is a strong argument. The question is it cogent? And we just don't know that. Why? Nobody counts horse hairs, so we don't know whether it's true that every observed horse has had an even number of hairs, because nobody counted the horse's hairs that they were observing. So the argument, what do we do with it? It's strong and possibly cogent, but possibly not cogent. So when we assess inductive arguments, we've got 4 possible evaluations that we might make, and these parallel the 4 possible evaluations we might make of a deductive argument. It's cogent if the argument is strong and the premises are true, and that means that the conclusion is probably true. It's possible, though, that the argument is strong but not cogent, like if one or more of the premises is false. And in that case, if the premises are false, it just doesn't give any support to the conclusion. You could have a case, though, where the argument is strong and possibly cogent, but we just don't know whether the premises are true. It doesn't do us much good if we don't know the premises are true. And then you might just say, this is a weak argument. Even if these premises are true, they don't strongly confirm the conclusion.